Hey everybody, Matt Cribbs here, and welcome to another Wednesday morning drive. A little bit wet today, wet one, which is good. No sun in my eyes, we like that. Hope you're doing well, I am doing great. It's been a good week. Hitman Beta came out, so I did some playing of that, got 2 up, and a couple more to come at least. It's a lot of fun. I am possibly the world's worst assassin. Every single one of my missions ends in being discovered and a complete and utter disaster. But I always manage to get away thanks to the lovely nonsensical exit criteria of these missions. But, you know, it's training, it's fun. I hope it's enjoyable. It certainly is for me. Other things going on, 1.9 is coming out, so we'll looking at doing that, seeing what breaks on vanilla, and I think Feed the Beast is going to be making a comeback, looking interesting that, but I don't know if it's going to be continuing on Infinity. We shall see, but we're doing some talking and thinking about that. Anyway, enough of the updates. Today I want to talk about something that's been in the news a lot, and it's the whole Apple, FBI, iPhone thing. And everyone has their opinions. It's an emotionally charged issue, as they say. People are, have very strong opinions one way or another on what should be done. But I don't necessarily want to talk about that. I don't want to talk about the politics of, the rights of what you think the FBI should do or not, or ignore all that stuff. I want to talk about what is actually possible. Because I think a lot of the discussion that's happening out there right now is, and granted, it's a technical subject, but like I said in a previous one of these, you need to know about the technical subjects. Otherwise, you're not going to be able to function in this modern world. So I want to talk a bit about that. And to start with, let's talk about what is a computer. Or a digital device. A phone is just a computer. So at its simplest, most basic concept, a computer is simply has 2 parts. It has a place where information is stored. It has storage, and it has a thing that does steps, that does work, that follows instructions. And that's really, really simple. Like, that's the super high level. So let's look at the information storage part, right? That's a hard drive, RAM, things like that, CDs, DVDs, all of those things are just where computers store data. And it stores the data as numbers, just numbers. It happens to be binary numbers, 1s and 0s. You've probably heard of all that. I would think so. But we store our data as numbers. Big, long strings, books of numbers. Even characters we write in a book, ASCII, Unicode, we translate them into numbers. 2 numbers, 1 and 0. That's it. Everything in the world we store in a digital form is stored as a number. That's how it works. And all the pictures we have, all the music we listen to, MP3s, all the movies, this video on YouTube, everything sent over the internet, it's all just big, long lines of numbers in a row. But not only the data, it's also the programs. The programs that work on those numbers, Photoshop, Minecraft, whatever you have it. Encryption software is also all just strings of numbers. So we are sitting out here, the entire digital world is one big pool of numbers. Some numbers we treat as images. Some numbers we treat as, programs, and it works. And you can see this if you've ever opened an image in a text editor. Choose like TextMate and a small image because it'll get really big. But you can actually see the numbers. They'll be represented as, well, it depends on the program you use to open it. But you can actually look at the numbers that make up an image and without looking at the picture itself, and you can see all those things. So that's what we're dealing with. The other half of what makes a computer is the well, what do we do with all these numbers? And that's, you know, the basic or the core component of that is the CPU, the actual computer part itself. And the other forms of it are like a video card, which just takes numbers, does things to it, and puts the result on an output that ends up on a screen. A CPU takes numbers, does things with those numbers, and sends it to other parts of the computer. Sound cards take numbers and turn them into sound. So everything, these are the doer bits of the computer system. They take numbers and they do things to it. And they take the two different types of numbers we talked about, the data, the images, the pictures, and the programs, and they treat them differently. So if you take say, you know, programs, operating systems, Windows, Paint, Photo Viewer, whatever it is, the computer has a very simple, for various terms of simple, but relatively a fairly small set of things it knows how to do with numbers. It knows how to, you know, take one number and move it from here to here. It knows how to take one number and add them together, subtract them, compare them, on and on and on. It knows how to do certain things with these numbers. And the program parts of the data that we store, the windows, the paints, all those numbers are big, long lists of those smaller things that a computer knows how to do. So if you look at the source code, the program for, say, Paint, it will say, take this number stored in this place and add it to this other number stored in this other place. And if you take all those different things and do them in enough order and do it over and over again, you get the fancy behavior from these programs. And you can build on top of each other, and those become the programs. And so you take a program that is just those sets of numbers, that list of instructions, and you take it to the data. So it will say, all right, this is the number that represents this top left corner of this image. Add it, you know, take that number from here and move it to over here. And this over here place is the place where the computer hardware will say, or the graphic processor will say, okay, this is a number, I will take it and put it in this spot. Simple. That's how everything works. It's all one set of numbers, taking the other set of numbers and using some very simple things that are built into the hardware. When they talk about the chip and the gates and the complexity and all those very simple instructions are built into the hardware. And there's a whole nother topic of how those are built. But, you know, it just happens to know that you feed in this number out here and it comes out another way. So, you know, that's what we're doing. That's what we're talking about. And I just somewhat lost my train of thought, but that's okay. So you take the program numbers and you take the data numbers and build them all up, and eventually you have a working computer system. And, you know, that's right. So I caught up. So, and sometimes they'll do things wrong. If you've heard about cracking or buffer overflows or website bugs that exist, a lot of security flaws that you might have heard about are basically you confuse the computer, you confuse the CPU and stuff that takes numbers that are supposed to be data, and it actually starts treating them as if they were program numbers. So you'll give it, because usually a program is written by someone you trust and it works and it's all fine. But if there's an error, a mistake in that program, it can take that image, that thing you downloaded off the internet, that whatever, and accidentally run it and and do whatever it says to do. And in doing that, it can break the way your computer works. It can let that program send data somewhere you don't want it to be. Send it over the internet. Send that number that represents your credit card number to a person you don't want to have it. So those are security flaws. That's basically really high-level hand-wavy how it works. So other things that happen, right? A lot, we take one set of numbers, run it through another program of numbers, and watch that movie on a screen. Right? We all want to do that. movie store on DVD, wherever it's stored, you're basically fundamentally taking the one set of numbers. You don't want to destroy it because you don't want to just watch it once, but you take it, you make a copy, you take a copy of those numbers and send them to the device with all the program instruction numbers and display it on the screen. So that's making a copy. You're taking one and putting them somewhere else to do that. Another way you could make a copy is take that set of numbers and put them somewhere else, and just store them again. And I've just made a copy of, Star Wars Episode 8, whatever it is. I've made a copy of that movie. Obviously, people don't want to do that. The people that own that movie do not want me to do that. Other people love to do that. We call them pirates and whatever they are. So people love copying numbers. But the problem is, since in order to watch the movie, you are taking that set of numbers and copying it to another place, the display, the screen, you can't, the same action, the same thing you do to watch the screen is what you, or watch the movie, view the data, look at the picture, listen to the music. That same act is the act of making an illegal copy of that movie or picture or whatever it is. So what do we do? How do we stop that? How do we stop one type of, copying when we need to do the other movies? And that's a big problem, because fundamentally, if an image, a PDF, a video, a sound file, if that can be read, viewed, listened to, displayed, it can be copied. Has to be, by definition, because that act of listening to it is copying it. So it's a very, very difficult problem of how do you selectively stop an action from happening. You can't say, I want to prevent illegal copies, but I still want people to be able to watch it. Because guess what? Those two things are exactly the same thing. Enter DRM. Form of encryption. Encryption is just math. Encryption is, at its simplest form, saying, here is your set of numbers, here is some math, the instruction set of numbers to do to that, and it is fancy, fancy math that only will let you view that data, use that data in a useful way if you know a secret number. At the end of the day, that's pretty much what all the encryption boils down to. Secret numbers of various sizes, various math tricks that you say, I will let you make a copy of this file. I will let you use this file, but only if you give me the secret number. And a lot of the encryption stuff that has grown up over the years is figuring out how to protect either the way that you do things, that algorithm, that program, that information of like, how do I decide whether the secret number is good or not, or protecting the secret number. Well, we found out that you can't really, trying to keep the information of how I do it secret is worthless. People will figure it out. And so we don't protect the algorithms. We don't protect the ways you encrypt it. All popular encryption methods are public. Everyone knows how they work. The trick is that we protect that secret number. And we make it so that you can't guess it, or guessing it would take longer than the universe has ever been around and never will be around. So it's impossible to guess it. We make it so that you can't figure it out by looking at the other data, because that you used to be able to do that, and still can in weak, broken, not even weak encryption, but fundamentally broken. I can look at the data you're doing and say, oh, your number is 3. And sure enough, it is. They're also much longer than 3. But I can guess it. So you protect. We have ways of doing this, and there's very, very strong algorithms that say, you know what, unless I have this number, you will not be able to do this, and they're secure. We've figured out ways that, we can keep that secret number safe. So unless you let it leak, unless you let out your encryption key, which is what we call those numbers, no one will have the time or ability to be able to look at your data. And you know, great. That's encryption. That's fundamentally what exists. And going back to the whole topic of this is, you know, the iPhone has this encryption. It has a way of, you enter a password on your phone, it uses that password. That is your secret number. It uses that and it runs through this math. And I don't know which encryption algorithm that the iPhone uses, but assume it's a very secure one. You run it through, and unless you know that secret number, that password, you cannot reverse the numbers. Now, it gets a little more complicated because actually, unless you want to enter a really, really, really long password, you know, that the password you'll actually enter on your phone is small enough that, given enough time and less than the time of the universe, given time and powerful computers, you'll be able to just guess it. If you enter it in enough times entering in that password, someone will be able to guess it. So that's why they add those things. If you guess 10 times wrong, it will just delete everything. Those are the special stuff built in, that if you do this, it will delete it. And that's so the chances of being able to guess the number, the secret number, in 10 times, that is astronomically, I mean, the odds are so far against. I mean, it could happen, but it won't. So that's it. Chances are it won't. So that's the strength of the encryption on the iPhone. They've have those protections on there, that the data is fairly safe because you only have 10 times to guess, and that's it. So what the FBI, what people are asking for, is a way around that, a way to avoid that, a backdoor, right? They want a way to just say, you know what, I'm the FBI. Just give me the data. I should have this data, so give me the data. But, you know, that is effectively, that's another way into the data. And it's only as strong, I mean, it's an encryption algorithm is only as good as the way to do it. The program doesn't care. The data doesn't care how you got the copy of the data. It just knows once you can read the data, you can read the data. It doesn't care who you are. So by asking for a way to say, if, you know, I am the FBI, I have this backdoor in to get this data, it's basically saying, all right, that other thing with the password and the very strong math and the 10 guesses and all that stuff, that doesn't matter. I don't even need to worry about this if I'm a bad guy. I don't have to care about any of that. All I have to do is figure out how to get in and say, I'm the FBI, which is a much, much simpler problem. And once that information is out there, and once that is built into a piece of hardware, built into a piece of software that's on there, once someone knows how to do it, the information will get out there. Because remember, these programs are just strings of numbers, and anyone can look at the numbers and figure out what it's doing, unless they're encrypted. And if you encrypt it, then you only can get it if you know that secret number. And once someone knows the secret number or knows how to get in, your encryption doesn't matter because they just enter the secret number and you see everything. So by asking for this way to get into the computer, it's making all the other protections completely worthless. So they're not asking that's why I think we're asking some of the wrong questions. It's not about, you know, should we do this? Should we do that? It's not about should the FBI have access to this? It's should we basically not encrypt anything? Should everyone have access to this? Because the concept that it will be, you know, only used once, or it will only be used by the good guys, or it will be only used when you want to, that doesn't matter. You can't program that in. Once there's a way to do it, it can be used by whoever has the secret information. And once that information gets out, it can't be removed. It can't be put back away. So the question is not, should, you know, Apple let the FBI into this one phone? It's, should Apple turn encryption off of your phone? Because that's effectively what they're asking for. That's the way the math and the numbers work. And so, you know, a lot of information is being thrown around, and there's opinions to be had. And I'm not going to tell you what you think what opinion you should have. I just wanted to clarify a bit. What are we really talking about here? Should we have no encryption available on our phones? Should everyone be able to see all of our data? It's a tough question. I mean, yeah, you can see the FBI could absolutely use this information to find criminals. Also, you know, people who I don't want to be viewing, you know, my emails could read it. Make up your own mind on that, but make sure you know what you're talking about and learn about how it works. So, hope it was useful. Hope that was a little bit of information. Hope it was clear. It's a really complicated subject, and the details are really interesting. There's actually a whole lot of stuff going on, but hopefully that made it a little clearer on what's actually going on. Till next time, always keep playing, and I will talk to you later. Bye.